Math 2, Unit 6, final review, fall semester. Just in case you didn't know, Unit 6 was about something called similarity. The word similarity had a lot to do with a key word. The key word was proportional. When something was similar, their sides were in the same ratios. Besides that key word proportional, we learned something called scale factor. Scale factor and proportional were really the same ideas. The whole chapter was about knowing whether something was similar or not similar. There were lots of different ways to figure out if they were similar or not similar, but similar meant the same shape but not necessarily the same size. It also meant that they were proportional. The whole chapter was knowing how to set up similar triangles so that you could figure out what was proportional or what side compared to which side so you can find missing sides. When I think about what we learned how to prove triangles similar. There were 3 ways to do it. The 3 ways were called angle-angle similarity, side-angle-side similarity, side-side-side similarity. These, if you had 2 angles congruent to another, 2 angles of a different triangle, those 2 triangles were similar. If 2 sides were proportional and one side congruent, the included angle, it was similar. Same thing, side-side-side. Being proportional would be similar to another triangle. So there were 3 different ways to prove triangles similar to each other. If you forgot that symbol right there means similar. We also learned that a altitude of a right triangle splits this up into 3 similar triangles. We did several problems just like that. As a matter of fact, that's the reason why we had some problems where if we were trying to find x, we could use the small triangle compared to the middle and comparing that to the small triangle in the middle of the middle triangle, like 2 over x equals x over 8. That's how we did those problems back then. We learned something called Sidesplitter. The 2 lines that were parallel would cut the sides into equal proportions. When we had the sides cutting those 2 things into equal proportions, we are not cutting RS and we're not cutting XY. What we are cutting is the side QR and RX and QS and SY. So many people confused this with the bottom. Don't forget, when you use the side splitter, we're only talking about the sides that are being cut by those parallel lines. There's also the corollary to the side splitter plus the triangle angle bisector theorem. These 3 things were used a lot in chapter 6 to prove this over that is equal to this over that. The left side over the bottom will equal the right side over the bottom, and so on. The last thing we covered in chapter 6 was something called dilations. Dilations are proportional. They are similar. We just had to know what happened when we dilated something, either enlarge it or reduce it. And the easiest thing that we did was taking the image, dividing it by the pre-image. If I want to know what the scale factor is, I just take the image and divide it by the pre-image. It doesn't matter if you're doing the right side and right side, or the bottom divided by the bottom, or the left side divided by the left side, or even the distance from the center divided by the distance from the center to another point. All of those will be equal to each other, and they will all be equal to that scale factor. We also learned how to do that with graphs and how to write rules with them. So that's Unit 6. If you need more, don't forget there's a video for 6.0, 6.1, 6, 2, 3, 4, and 5 on my website if you need anything explained further.